Welcome everyone to our fractions series. We are in the JSCE aspect of it. The word fractions means part. When a whole orange is divided into parts, the result is fraction. A piece of chalk can be divided into parts as we please. Say, as shown below, the unshaded parts of the chalk are, in the case of A, chalk A is half, the unshaded part is half. In the case of chalk B, the unshaded part is 1/3. In the case of chalk C, the unshaded part is 1/4 because the chalk is divided into 4. In the case of D, the unshaded part is 1/5 because the chalk is divided into 5 different portions. Any fraction is never whole or full. Every fraction has a numerator and denominator as shown below. I, 2/3. The 2 is the numerator and the 3 is the denominator. I, 6/5. The 6 is the numerator and the 5 is the denominator, which is 3. One whole number, 5/7. Here, 1 is the whole number. This is a mixed fraction. Here, 1 is the whole number. 5 is the numerator and 7 is the denominator. Proper and improper fraction. Any fraction whose numerator is smaller than the denominator is called a proper fraction. It can be said to be a fraction that is carrying small load. Example, 1/2, 2/3, 10/17, 15/103. On the other hand, improper fraction is any fraction whose numerator is bigger than the denominator. It can be thought of as a fraction that is carrying big load. Example, 3/2, 17/10, 103/15. Let's take some examples. Which does not belong to the group? The options are given. Solution. From observation, we can see that all options are proper fractions except C, which is improper fraction. Another example. Express 9 whole number 6/11 as improper fraction. The options are given. Solution. 9 whole number 6/11 is equals to, at the denominator we have 11, 9 times 11 plus 6, which is equals to 105/11. As we use 11 to multiply 9, then add 6 to it. That's what will be adding numerator. Next, mixed numbers or mixed fractions. When we have fractions and whole numbers together, it is called mixed number or mixed fraction. Example, 1 whole number 5/7, 4 whole number 2/3, 10 whole number 1/2. We usually change mixed numbers to improper fraction before solving when working with fractions. Let's take our first example. Express 100/12 as a mixed fraction. The options are given. Solution. 100/12 is equals to 8 whole number 4/12. Thus 12 can go into 100 8 times and you'll be left with 4. 12 going into 100, we're talking about 8 times 12 give you 96. So we have 4/12 left. And that 4/12 will reduce further to 1/3. So we can now have our answer, final answer as 8 whole number 1/3. Another terminology used in fraction, reduce to lowest term. When asked to reduce a fraction to its lowest term, we simply divide the numerator and denominator by a common number until no other number can divide through. Let's have some example. Reduce 12/36 to its lowest term. Options are given. Solution. We simply cancel out gradually till there is no more common terms. Thus, 12/36 will be equals to 3/9. 4 divide 12 will give you 3. 4 divide 36 will give you 9. And 3 can now divide through. 3 divide 3 will give you 1. 3 divide 9 will give you 3. That's why you have 1/3 there. Alternatively, we can divide directly as 12/36 equals to 1/3. 12 going to 36 will give you 3. Let's take another example. Reduce 105 divided by 147 to its lowest term. The options are given. Solution. We shall continue to divide numerator and denominator with common number until it cannot be simplified further. Thus, our 105 over 147 will be equals to 15 over 21. Using 7 to divide through both the numerator and the denominator. Now 15 over 21 will be equals to 5 over 7. Using 3 to divide through numerator and denominator. And that's the simplest form we can obtain. Another terminology under fraction is multiple fractions or equivalent fractions. Let's take our first example. Which of the following fraction is the same as 4 over 7? The options are given. Solution. In equivalent fractions, whatever number used to multiply the numerator, the same number is used to multiply the denominator. That is multiples of original fraction. Thus, 4 over 7 is the same as 28 over 49. That is 4 over 7 times 7 over 7. Another example. Which of the following fraction is the same as 7 over 10? The options are given. Solution. 7 over 10 times 2 over 2 is the same as 14 over 20. That is original fraction and its multiple of 2. Next, we take on the new subtopic, addition of fractions. I simplify 1 over 3 plus 1 over 3. Solution. First, we find the LCM of the denominators. In this case, it's 3. So the LCM will still remain 3. We now have our given problem, which is 1 over 3 plus 1 over 3 will be equals to, denominator is 3, which is the LCM. And when 3 divide 3, you have 1. 1 times 1 plus another 1 times 1. And 3 divide 3 is 1. 1 times 1 at the numerator. And in the other case, the same thing. Our result will be 2 over 3. Another example. Simplify. 1 over 5 plus 7 over 10. Solution. First, we find the LCM of the denominators, which is 5 and 10. By simply ruling our line, we impute the number 5 and 10. And then, first, we take 5 to divide 5, and that will give you 1. 5 divide 10 will give you 2. Remember, we are using our prime factors to divide. Next, we take 2. 2 divide 1, bring the 1 down. 2 divide 2 will give you 1. Thus, our LCM of 5 and 10 is the same thing as 5 times 2, which is equals to 10, which is 1 over 5 plus 7 over 10 to be equals to, the denominator will put our 10. Now, when 5 divide 10, will give you 2. So, we use 2 to multiply the 1 at the top. Then, in the next fraction, when 10 divide 10, give you 1. So, we use 1 to multiply the 7. Hence, the description you see at the numerator. And the result will be equals to 9 over 10. Another example. Simplify. 1 whole number 5 over 7 plus 4 whole number 2 over 3. Solution. First, we change mixed numbers to improper fraction. Thus, our given problem, which is 1 whole number 5 over 7 plus 4 whole number 2 over 3, will be equals to 12 over 7 plus 14 over 3. What happened there? 7 times 1, 7 plus 5 give you 12. In the second fraction, mixed number become turned into improper fraction. You have 3 times 4 plus 2 give you 14 over 3. We can now find the LCM of the denominator of 7 and 3, which is 21. But it's gotten as, you rule your line, you insert the numbers 7 and 3. First, you can take 7, is still a prime factor there. 7 divide 7 give you 1. 7 divide 3, you bring the 3 down. We are dealing with LCM. So you go with 3 now. 3 divide 1, give you 1. Bring 1 down. 3 divide 3, give you 1. We can now say LCM of 7 and 3 is the same thing as 7 times 3, which is equals to 21. Our given problem, which is now in improper fraction, 12 over 7 plus 14 over 3 will be equals to, put the LCM at the denominator, which is 21, And in the first case, 7 divided 21 will give you 3. 3 times 12 will give you 36 plus 3 divided 21 will give you 7. 7 times 14 will give you 98. Hence, the value written at the numerator there, which is equals to 134 over 21. And that will give us 6 whole number, 8 over 21. Another example. Solve 1 over 5 plus 3 over 10. The options are given. Solution. We apply the LCM of the denominator of 5 and 10, and that is 10. So our given problem become equals to, we have 10 at the denominator, and in the first fraction, 5 divided 10 will give you 2. So we have 2 times the 1 that is there at the numerator. Plus, in the second case, 10 divided 10 will give you 1. 1 times the 3 that is there. And that will give us equals to 2 plus 3 over 10, which will give us 5 over 10. And that reduces further to 1 over 2. Next, we treat subtraction of fractions. Simplify 1 over 2 minus 1 over 3. Solution. LCM of the denominator 2 and 3 is 6. Thus, our given problem, which is 1 over 2 minus 1 over 3, will be equals to, at the denominator we have 6, and at the numerator we have 3 minus 2. Why is it so? 2 divided 6 will give you 3. 3 times 1 is 3. 3 divided 6 will give you 2. 2 times 1 is 2. So, and that will give us equals to 1 over 6. Another example. Simplify 5 minus 1 over 4. Solution. 5 minus 1 over 4 is the same as 5 over 1 minus 1 over 4. LCM of 1 and 4 is 4. Thus, our given problem will be equals to, at the denominator you put 4, and 1 divided 4 will give you 4. 4 times 5 will now be 20. In the second case, 4 divided 4 is 1. 1 times 1 is 1. So you have minus 1, which will be equals to 19 over 4, which is equals to 4 whole number, 3 over 4. We've come to the end of the teaching in this session of fraction under the JSCE series. Next, we have some exercises which are taken from page 29, 30, and 31 of the hidden fact in JSCE mathematics. Try your hands on the exercises. Answers are provided at the answer section of the book, either the hard copy or soft copy. Thank you.